Let's go over section 1.7. Match the inequality x is less than -1 with its equivalent interval notation. Let's draw a picture of what this represents. We have -1, and in this case we're going to have an open circle because it's just a less than symbol. It's not included, so we're going to have an open circle. And it points to the left, so I'm going to shade to the left here. And so my interval notation is going to be to the left forever to the negative infinity side, then it goes to -1, and since this is an open circle, we're going to use the parentheses. So which option satisfies our interval notation? That's option B. Let's go on to question 2. Again, for question 2, let's draw our number line. We have an 8, and it's a closed circle this time because of that equal sign underneath. So we have a closed circle. It still points to the left, so I can read it from left to right. This is negative infinity on the left side. It goes to the right 8, and this is a closed circle, so we'll use a square bracket. And that option is option D. Question 3. Match the inequality with its equivalent interval notation. In this case, I can draw my number line again. I have a -2 here. That's an open circle because it's just a less than. And this is a less than or equal here on the right. So we have 5 on the right. And that's going to be a closed circle because of that equal sign. I'm going to shade in between. And so my interval notation is going to be -2 to 5 with the parentheses around the -2 because it's an open circle, and the 5 is going to be a square bracket. And that's option F. For question 4, let's find our solution. I want to get the x on the left side. Let's solve for x, and I want the x on the left side. Let's subtract 4x to both sides. I have -3x minus 1 is less than or equal to 5. Let's add the 1 to both sides. We have -3x is less than or equal to 6. Divide both sides by -3. That causes the inequality to switch directions. So we have x is greater than or equal to -2 now. Now we can draw our number line. For the -2, it's a closed circle. Since there's an equal sign underneath, it points to the right because we're looking at all the values that's greater than -2. And so this is a square bracket, -2, and it goes to the right forever, and we'll use a parentheses. This is our interval notation. For question number 5, again I want to have x on the left side when I solve these because it tells us which direction the arrow is going to face. First we'll distribute the 2. I have 2x plus 12 plus 3 is greater than or equal to 7 plus 3x. I can collect like terms. 2x plus 12 plus 3 is 15, and that's greater than or equal to 7 plus 3x. Let's subtract 15 to both sides, and that results in 2x is greater than or equal to -8 plus 3x. Let's subtract 3x to both sides, and we have -x is greater than or equal to -8. But when I divide both sides by -1 to get the x by itself, I have to switch the direction of the sign. And so we have x is less than or equal to 8. Let's draw our number line again. We're going to face to the left here, and it's going to be a closed circle. Now our solution is -infinity to 8 with a square bracket around the 8. Question 6, let's solve the inequality. I don't like this fraction on the bottom, so let's multiply everything by -3. We'll multiply -3 on the left side and on the right side. As a consequence, this -3 and this -3 will divide out. So we have 2x plus 7, but since we multiplied by negative, we're going to have to switch the direction of the sign. This is actually greater than or equal now to -6x minus 12. And I got this from distribution here on the right. Let's get the x on the left side, so let's add 6x to both sides. This gives us 8x plus 7 is greater than or equal to -12. We'll subtract 7 to both sides. 8x is greater than or equal to -19. Let's divide both sides by 8. And I have x is greater than or equal to -19 over 8. What we need to do now is graph it on the number line. And -19 over 8 somewhere on the left side. It's going to be a closed circle. And this points to the right, so we're going to shade to the right. Now, what's our interval notation? It's going to be a square bracket, -19 over 8, and it goes forever to the right. So this is our interval notation. -19 over 8, comma, infinity. Question 7. The cost to produce x units of wire is C equals 45x plus 450, while the revenue is R equals 70x. Find all the intervals where the product will at least break even. So in this case, I want to make sure that the revenue is at least so greater than or equal to the cost. And in this case, we have 70x is greater than or equal to 45x plus 450. Let's subtract 45x to both sides. This gives us 25x is greater than or equal to 450. Let's divide both sides by 25. And so x is greater than or equal to 18. And so we can draw our picture. I always like to draw the picture so I can make our interval notation. This is a closed circle and it points to the right. This means our interval is from 18 to infinity. So we're going to break even if we produce at least 18 units. Let's get started. Question 8. Solve the inequality. Give the solution set in interval notation. For these compound inequalities, let's keep the x in the middle. Since we have two inequalities, let's make sure the x is in the middle. I will subtract 3 from all three sides. This gives us -12 is less than 2x. That's less than 6. Let's divide everything by 2 now to all three sides. I have -6 is less than x, and that's less than 3. We could draw a picture now. I have open circles for both the -6 and the 3, and we're going to shade in the middle because x is in the middle. X is trapped between -6 and +3. So here's our solution in interval notation. It's -6 to 3 with parentheses around both of these numbers. Question 9. Again, we want to keep that variable in the middle, so let's subtract 20 to all three parts. I have -3 is less than or equal to 3y, and that's less than or equal to 0. Let's divide everything by 3 now. We have -1 is less than or equal to y, and that's less than or equal to 0. This tells me we have, again, another trap where
the variable is in the middle. We have -1 and 0. These should both be closed circles because of the equal sign, and we're going to shade between. This tells me -1 to 0 is our solution with square brackets around each of these numbers. Question 10 is where things get interesting. For these, let's find our zeros first. This is a quadratic inequality. It's not a linear term, so we're going to have to factor first. Let's find the zeros. X squared minus 2x minus 8. I'm going to set that equal to 0. And so we have, this does factor as 4 and 2. We have a -4 and a +2. So this is x minus 4 times x plus 2 is equal to 0. So here's my two zeros. X is equal to 4 or x is equal to -2. Now from here I'll do my number line. We have a -2 and a 4. Both of these will be open circles because this is when the quadratic is equal to 0. I don't care about when it's equal to 0. I want it to be strictly greater than 0. So we want to leave these as open circles because these are not part of our solution to this inequality. Now, since they're exactly 0 at -2 and 4, the other intervals would be strictly positive or strictly negative because we know it's exactly 0 only at two locations. So you're either positive or negative anywhere else. And to find out, we'll have to pick some test points between our zeros. So what's a good number to the left of -2? Let's test x equals -3. What's a good number between -2 and 4? You can pick whatever you want. I'm going to test x equals 0. And to the right of 4, let's test x equals 5. So we'll plug in -3 into our quadratic and we'll check to see if it's true or false. So -3 squared is 9. That's 9. -2 times -3, that's 6. Minus 8, that's going to be a positive number. That's definitely going to be greater than 0. So this is true. This is true. Since it's true, we know the solutions is going to be on the left side of -2. Now we'll test x equals 0. I like to pick 0 whenever I can. It makes our lives so much easier when we can plug a 0 in. This is going to be obviously -8, and that's clearly not greater than 0. That's false. So we don't shade in between. Now we'll plug in 5. We have 25 minus 10 minus 8. That's clearly bigger than 0. This is true. Since this is true, we'll shade this side. And now I could write my answer. This goes to the left forever to -infinity. Then it goes to -2. And we'll union that with 4 to infinity. And this is our interval notation. So pick some test points, anything to the left of -2, anything between the two zeros, and then to the right of the 4. Question 11, we're going to do the same process. I'm going to subtract 15 to both sides first because I want the right side for this quadratic inequality to be 0. And now we need to see if this thing factors. So let's hope it does. We have 5 times -15. That gives me -75 on the top. And we need to find two numbers that multiply to get negative 75 and add up to 22. That's 25 and 3. This has to be a negative 3. Now since this is the AC method, we're going to have to split the middle. And that is rewritten now as 5x squared plus 25x minus 3x. Again, we split the middle with these two numbers. And now we can do factor by grouping. The first two terms has a 5x in common. What's left over? X plus 5. The second terms have negative 3 in common. What's left over? X plus 5. And now this factors as x plus 5 times 5x minus 3 is less than or equal to 0. Now, the first step for these problems is to find where our zeros are located. Our zeros are located at x equals negative 5 or at x equals 3 over 5. And where did I get these answers from? Well, I set each of our factors equal to 0. Now we can draw those on our number line. And since we have a less than or equal symbol, these are included in our solution set. Now let's pick some test points. Let's test to the left of negative 5. I'll test x equals negative 6. And here I'll test x equals 0. That's an easy number to use. And to the right of 3/5, let's test x equals 1. So you can plug in negative 6 into the x values here and check to see if it's true. We have 5 times negative 6 squared plus 22 times negative 6. Is that less than or equal to 15? On the left side, I have 158 is less than or equal to 15. That's false. That's not true. So don't shade to the left of negative 5. Now we'll test again, x equals 0. So we have 5 times 0 squared plus 22 times 0. Is that less than or equal to 5? Obviously this is 0 less than or equal to 15, I meant to say, and this is true. So we're going to shade between. If we plug in a 1, we have 5 times 1 squared plus 22 times 1. Is that less than or equal to 15? No, that's clearly false. That is 27 is less than or equal to 15. That's false. So don't shade anything to the right. So what is our solution? Our solution is going to be from negative 5 to 3/5. Question 12. So let's solve the quadratic inequality x squared plus 7x plus 18. So the first thing I want to do is see if I can find those zeros. Let's set x squared plus 7x plus 18 equal to 0. And let's try to factor. Now we need two numbers that multiply to get 18, but add up to get 7. If you think about it for a while, you'll realize it's not factorable. So we cannot factor this. We'll have to use a different technique. Let's use the quadratic formula. We have a is equal to 1, b is equal to 7, and c equals 18. Again, recall the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times 8. We can plug in our values. We have x equals negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 18 divided by 2 times 1. And we can simplify this as negative 7 plus or minus the square root of negative 23 over 2. Now, we have a negative radical, so this implies x equals negative 7 plus or minus I root 23 over 2. Now this is an imaginary number. What does that tell me about the zeros? There are no zeros. So this implies that this graph contains no zeros. Remember, we're talking about a parabola here that faces up. And it does not have any zeros, which means it does not cross the x-axis at all. So when is this graph ever going to be less than 0 if it's strictly above the x-axis? Well, if you're not sure, why don't we pick a test point? Let's pick any test point that we want on the number line. I'm going to pick 0 since that's easy to do. So let's test x equals 0. Since we don't have any zeros, we'll test any point on the number line. We have 0 squared plus 7 times 0 plus 18. Is that less than 0? Is 18 less than 0? No, that's false. That means any point that I pick on the number line is going to be false because this parabola will never be less than 0. So what's our solution? If every interval on the number line is false, this has no solution. Question 13. We want to solve the inequality x minus 5 over x plus 6 is less than or equal to 0. Again, we'll try to find the zeros. That's where the numerator is equal to 0. So x minus 5 is equal to 0. This implies x equals 5 is a 0. Now for the denominator, this is not where we have a 0. This is where the graph is undefined. We have x plus 6 equals to 0 is undefined because you can't divide by 0. And in this case, we have it being undefined at x equals negative 6. Now when I draw my number line, at 5, it's a closed circle because of this symbol. It's a less than or equal. But at negative 6 is an open circle because it's undefined. You can't divide by negative 6. So now we'll have to pick some test points. Anything I want between negative infinity and negative 6, I'm going to pick x equals negative 7. Anything I want between negative 6 and 5, let's pick x equals 0. Anything to the right of 5, let's pick x equals 6. Anything that you want, as long as it's in those regions. So let's plug in negative 7. Negative 7 minus 5 over negative 7 plus 6. Is that less than or equal to 0? We have negative 12 divided by negative 1. And that's positive 12 is less than or equal to 0. That's false. So don't shade to the left of negative 6. Now let's test x equals 0. That is true. Negative 5 over 6 is indeed less than 0. So I shade between. Let's check 6 now. We have 1 over 12, and that's not less than or equal to 0. This is false. So we don't shade to the right of 5. And so what's our solution? Our solution is going to be negative 6 to 5. Question 14, I want the right side to be 0. Because we can solve inequalities if the right side is 0, it just makes our life so much easier. So let's subtract 1 to both sides. Now we have the 0 that I want. But unfortunately we have fractions on the left side. So let's rewrite 1 as x minus 1 over x minus 1. Now the reason this is equivalent to 1 is we have the same number divided by the same number, so it must be equal to 1. That means I can distribute the negatives, and we have x plus 4 minus x plus 1 over our common denominator now of x minus 1 is less than 0. Now this would cancel out, and we get 5 over x minus 1 is less than 0. And now, if you look at our zeros, there's really none because the top can never be equal to 0. So there's no 0 in this case. So there's none. Now for the undefined, well, you can look at the denominator. When is that equal to 0? Well, it's equal to 0 when x equals 1. So when I draw my number line, I only have one spot where it's of concern, and that's at x equals 1. Now this must be an open circle because it's undefined. Since it's undefined, it has to be open. Now I have to test to the left of 1 and to the right of 1. Let's test x equals 0 first. Is 5 over 0 minus 1 less than 0? Yes, that's true. So we shade to the left. And then we'll test a number to the right of 1. Let's test x equals 2. And this is also true. 5. Let's test to the right side of 1. I'm going to test a 2. 5 over 2 minus 1, is that less than 0? No, that's false. So we don't shade the right side. What's our solution? Our solution is going to be from negative infinity to 1. For question 15, again, I want this to be 0 so we can find our zeros and where it's undefined. So let's subtract that number to the other side. This gives me 6 over x plus 2 minus 1 over x plus 2 is greater than or equal to 0. We can add these fractions. That's 5 over x plus 2 is greater than or equal to 0. And again, this has no place where the numerator is equal to 0. It's none. We don't have any places where the top is equal to 0. Where is it undefined? Well, it's undefined when x equals negative 2. So at negative 2, make sure you use an open circle. It's undefined, use an open circle. Now, where are we going to shade? Well, I have to pick test points. Let's test x equals negative 3, and we'll test x equals 0. Those are easy numbers to use. 5 over negative 3 plus 2. Is that greater than or equal to 0? Well, there's going to be a negative on the bottom, so this is false. This is false, so don't shade to the left of negative 2. Is 5 over 0 plus 2. This time I'm plugging in a 0 to do a test point. And yes, this is true. So we shade to the right side of negative 2. And now we can come up with our solution. Our solution is negative 2 to infinity. For question 16, it's very similar to the previous problems. We'll have to get this to be a 0. Let's subtract it to the other side. Now we have the right side as 0. Now, again, I can replace this 1 with something with the same denominator. Let's choose x minus 6 over x minus 6, because then we have common denominators. We'll distribute the negative. We have negative x plus 6 over x minus 6 is now less than or equal to 0. The x's cancel out, and I have 8 over x minus 6 is less than or equal to 0. Now, where is this thing 0? Well, if you look at the top, that's not going to happen. There's no x's up there, so we don't have any zeros. But we do have a place where it's undefined. It's undefined at x equals 6, when the denominator is equal to 0. So let's go to our number line, and we're going to put an open circle at 6 because it's undefined there. And let's test to the left and to the right of 6. I'm going to test x equals 0, and I'm going to test x equals 7. Now, you can go back to the original equation and plug it in, or you could use this equation. It's up to you. It'll both work. So I'm going to use this one. It's a little bit easier to see. So we'll plug in a 0. Is that less than or equal to 0? 8 divided by negative 8? Yes, that's going to be less than or equal to 0. So we'll shade to the left side of 6. Let's look at the right side of 6. That's 7. Is 8 over 7 minus 6 less than or equal to 0? No, that's false. That's 8. 8 is not less than or equal to 0. That's false. Don't shade to the right. So now we can write our solution as negative infinity to 6.